30-second presentation, talk about what they did this summer. And this will be moderated by my co-PI, Professor Niels Lobo. And then we will have the presentation of certificates by President Cartwright, and we will end this by the concluding remarks by the President. So let's get started. And after that, we'll have poster session, which will be separate for each student. And there are links on your chat on the side, which you can access. So let's get started. This is kind of brief overview what we have been doing and a little bit history also. So the aim of REU from NSF is that to attract the talented undergraduates into research. And this is probably the longest running program within NSF, which was started around 86. And 86 for the year, I joined UCF. And I used to look like this, pretty naive and innocent, inexperienced. And this was my first proposal I wrote. And I was really surprised that it got funded. And we started our first REU 1987 in the summer. So now it used to be that we had to submit this proposal every year. So I was so inexperienced, so I didn't know that I had to submit in 88. So actually missed the announcement, I didn't have this site. Then we got together with Professor Boyer at USF and Professor Krishna Ganapati at Stetson University here in DeLand, and we submitted a proposal. So we got funded 89, and then we keep submitting every year, 90, 91. And then we submitted with Boyer, we got funded for 2 years. Then 94, Professor Niels Lobo joined UCF, and we submitted joint proposal, but somehow Professor Lobo was a bit greedy and the budget was too much. So unfortunately, the proposal was not funded. And this was only year we did not get funded. Then we put together a team of Professor Boyer, Professor Lobo, and Louis Stark. We got funded for 3 years. And then we included Art Weeks from EC. We got funded for 3 years. We continued this with another professor, Kasparis from EC. We were funded for 5 years. And then we continued 3 more years. In 2007, we actually celebrated this 20-year anniversary of the NSF REU in computer vision at UCF. We invited all the alumni, and we have a day-long celebration. So we're very happy about that. And 2009, we had Marshall Tepin join UCF. So we submitted a proposal, got funded for 3 years. Then we had Rahul Sutankar, who's now at Google Research, submitted a proposal in 2012, got funded for 3 years and 3 more years. Then in 2017, we celebrated a 30-year anniversary of REU in computer vision at UCF. So at that time, we had about 300 students from, who published about 79 research papers. They were from 68 different institutions. It was a big thing for us. And actually, NSF Deputy Director of SAIS, he came and gave us a plaque, and it was one-day celebration with all the alumni joining us in this event. And we summarize our model in this article in Communication of ACM. So in 2018, we had Professor Lee Burji join the team, and we got this funded for 3 years. And now this year, we are writing another proposal, which we'll submit in August. So the key elements of our REU are that we have full summer experience for undergraduates. And actually, it used to be a whole year, but NSF wanted us just in summer. And we immerse the participant in full research environment. We give them a spot in a lab. Of course, this year we couldn't do it. And they or like a graduate student, they will interact with postdoc, graduate student faculty, and so on. So also we present several possible projects to work on and offer optional follow-on through the year. And we take them for field trips to local companies like Lockheed, Harris, and other startups. And also we have social events. So the program starts with recruiting. We get about 150 applicants. We recruit 10 of those. Then we have this short course in computer vision because we assume these are the computer science EC major. They don't have any background in the specialized area of computer vision. So we teach them quickly the computer vision and then teach them programming. And then they select the research projects and then they work on research projects. And each student is assigned a graduate student mentor and a faculty. And I conduct this half-day workshop why they should go to graduate school. And we have students with a former NSF fellowship winner, they join us, and the computer science graduate coordinator and associate dean from the College of Graduate Studies talk about different fellowship opportunities and so on they have. The program ends by writing a technical report, which can become a research paper, and also the poster session, which we are going through today. So student activities involve lots of meetings, with individual meetings with graduate students, mentors, faculty, weekly reporting meetings, vision group meetings. We have them attend the PhD defenses to feel that, what is a PhD about, research, and like PhD candidates exam, and they attend the colloquium by different researchers who visit UCF, and we take them to field trips. And also we have important part of social. We take them lunches, dinners, and so on. And actually we end by a banquet. Now with this COVID, last night we had a banquet through DoorDash. So it was pretty interesting that people in different cities, they were eating this good food, and we communicated and talk about the program. So measure of success is that we have 330 undergraduates from 80 institutions from 34 different states in the country have participated. Roughly half of them have gone to graduate school, and they have co-authored more than 80 papers, and 20 students have written honors and major theses, and several participants are faculty members. Some have started own companies. So for example, Ma Salam from USF has a startup which revenue is with $20 million. Robert Francis Cheney, he's got a PhD at UCF. He's a SAIC fellow. Adam Hoover, he's a professor at Clemson University. Jim Davis went to MIT. He's a professor at Ohio State. Michael Wallach got a PhD from University of Wisconsin. He received several awards from NASA. Tamara Miller went to Berkeley, got a PhD. She's an associate professor at UNC. Paul Smith got a very good Warner Award, first ever for UCF, and he finished his PhD at UCF. Ankar Datta got a CRA Outstanding Undergraduate Award, got a PhD at CMU. He's now at Amazon. John Prokridge got a PhD at USC. He has a startup company. Vlad Riley got a PhD at UCF. He works for Harris. And Andrew Miller got a PhD at University of Maryland. He's a professor at UIUC. Alan Wright got a CRA Outstanding Award. And Arjun got an Order of Pegasus Award from UCF. And Irene Tanner received Honors Graduate Thesis Award and NSF Fellowship this year. So it won't be possible to show you all the students who have participated, but I can show you quickly the institutions. So these are the institutions, or list of those from different states. We have hosted these students over these years, and we are very happy about this program, which we have done so far. So these are the participants for this year, and I would now hand over to my co-PI, Dr. Niels Lobo. who has been involved since 95. After the first rejection, he has been in every proposal, and he does the most of the work. Without him, I would not have continued this program for many years. Niels, now take over.
Thank you, Dr. Shah, for that introduction. And so now we're going to go ahead and I welcome you all to the spotlight presentations, where each student will present for about 90 seconds. They'll give you a little bit of background, a little bit of motivation, and then we'll talk a little bit about their results. Okay, so we're going to begin now. I turn it over to Robert.
Thank you, Dr. Lobo.
Hello, everyone. My name is Matthew Alici, and I've been working with Kevin and Jody on moving beyond frame-based video object segmentation. So the motivation and goal for this video object segmentation is when you have an object instance and you want to separate it from the entirety of the video, given that you have its first frame annotation. So the current methods for doing so are frame by frame, which are very inefficient since they don't take into account motion data. So we propose a multi-frame approach that's similar to action recognition methods, and we do this using the YouTube VOS dataset. So this is an overview of the model we created for doing this. So it takes in two inputs. We have a video input that's over 30 frames, as well as the first frame and its annotation, which goes into a initializer, and then from there goes into a LSTM at multiple spatial resolutions to help with performance. And then while that happening, the input video goes into an encoder, and then both of those go into a decoder, where it then outputs the segmentation for the input videos. And here's some of the results that we've pre-produced. You see on the left, this is the qualitative results, and on the right, this is the progression of our quantitative results as we've progressed to the REU. And you can see our highest score we managed to get was a 0.598. Yeah, that's it. Thank you.
Hi, my name is Jenna Bates. I'm a rising sophomore at the University of Central Florida, and my project is about learning tattoos to full facial recognition algorithms. I worked with Xiaoyu Sheng and Ajmal Mian, who are also from the University of Central Florida. So what is an adversarial attack? We're making subtle modifications to each pixel in a way that we can add invisible noise to an image, causing it to be misclassified by a model. So for example, if you add noise to an image of a pig, it could be misclassified as an airliner. So we used a projected gradient descent attack, which is just adding small noise using gradient descent. So our goals for this particular project was just to create a adversarial attack that's localized to a small area of the face rather than the whole face, which causes the person to be misclassified as a completely different person with facial recognition algorithms. So as you can see, we localized it to one section of the face, achieving a 40% full rate, and hope to raise it to be higher than that in future times. Thank you.
Okay.
I'm Callie Carter from Turner University, and I'll be talking about an approach for data efficient action recognition and mitigating scene bias. So our project goals include obtaining a competitive top 1 accuracy for action recognition on UCF 101 with no pre-trained weights, and then combining this with a method for mitigating scene bias. So first, data efficient action recognition. Our method is shown in the figure. We used various spatiotemporal resolutions a two-stream network, as well as a multi-validation strategy that increased our performance as well as reduced computational cost. And then after training all the models individually, we also performed an ensemble experiment with them. The results for the ensemble experiments are shown in bold, and then our final fusion result is shown at the bottom of 91%. This method helped us win first place at the VI Priors Action Recognition Challenge. On to mitigating scene bias. So our method is also shown in this figure. UCF 101 has scene bias, and so our way of mitigating this was to take the frames that we were using from a video clip and shuffle them so that they were out of order and send it through our encoder. Our hypothesis was that because the frames were out of order and it wasn't a coherent video, it would be classified as background. So our results improved us, our accuracies around 3.5 to 4%, which is an improvement over Choi et al.'s method. Thank you.
Hello, so my name is Pedro Contepelli, and this REU I worked on video anomaly detection with Mr. Praveen. So to explain what is video anomaly detection, you have to know that an anomaly is simply any deviation from what is normal or expected. And as you can see on the right side here, we were specifically detecting crimes from the UCF crimes dataset of many videos. Our approach was to use an encoder-decoder architecture to predict certain features given the original features and compare them to compute a loss. Additionally, we also used multi-head attention, which allowed us to get a better contextual understanding of the features that make up an anomaly and how they're dependent on each other. As for some results, here they are in a table with the current state of the art. We showed that with our model, we were able to get a 1.02% improvement when we used self-attention as opposed to without it. For some visualizations, we were able to actually see the attention map activations when an anomaly was detected for many videos, such as an explosion, in the region of the video in which the anomaly was detected. As you can see in the normal video, they were very plain. Thank you.
Hi, can you hear me?
Yes.
Okay. Hi, I'm Tamik DeBrito. I've been working with Dr. Yeshua on arbitrary predictive coding. Yeah. Okay, so main points. We present a variant of predictive coding we call arbitrary predictive coding and incorporate it into action recognition in both fully and semi-supervised settings and evaluate the improvements gained by this approach. Additionally, we present a new loss function we call partition loss that aims to utilize dataset structure to factor representations into different components, kind of like disentangled representation learning. Okay, so this is the normal approach to predictive coding. You encode an input sequence into a latent sequence and apply an autoregressive model to an initial segment of that sequence, then use the state of the autoregressive model to make future predictions. In contrast, we propose arbitrary predictive coding, which aggregates representations from arbitrary time steps into a global representation, which is then used to predict the embedding at a target time step. Okay, so what we found so far, testing this approach using the i3D encoder on UCF 101 dataset, applying the architecture to the i3D improves accuracy by about 12.3% over i3D by itself. 1 to 2% of this is due to predictive coding. Also, the partition loss shows some evidence of doing what it was intended to do. Yeah, that's it.
Hi, I'm Joe Fioresi. In the summer, I worked with Rohit Gupta and Dr. Christopher O. Davis on a project called Deep Learning for Defect Classification of Photovoltaic Module Electroluminescence Images. So the main project was part of a large-scale photovoltaics project dedicated to understanding contact degradation in solar modules. So their main goal is to create an automated system that non-destructively analyzes critical parameters of PV modules, which would be very useful in the module manufacturing industry. And so our current model goal is to take in these electroluminescence images, classify and localize their defects with the segmentation map, and be able to differentiate between up to 8 different defects. So our basic workflow is that we take in these EL images, they are annotated by a team of expert annotators and produce the target annotation seen on the right. At the same time, they're run through our defect classification and localization model, which is a fully convolutional network and the prediction segmentation map is outputted. It's compared to the target and with the cross-entropy loss function, and the weights are updated appropriately. Then for our results, you can see for the most part, it picks up on defects and is able to localize them. It'll miss some smaller ones here or there. Obviously, that's something we're working on. And it does not separate very well, but we kind of decided that that's okay for this application. We achieve a pixel level global accuracy of 91.6% and a best mean intersection over union score of 63.36. Thank you.
Hi, my project is Wildlife Action Recognition. I'm Wayne Lee and my mentor is Sweta. So most action recognition systems are human-centric, and what we want to do is, given a video like this, recognize that it's a cheetah hunting a deer. And this is difficult. This is difficult because different species of animals move very differently from one another. We drafted a data set with 106 categories, 100 videos per category. It has 32 animals with 3 to 4 actions per animal. And we're using a subset of this for our experiments. We had a few approaches. The first one is a I3D only approach. The second one is a fusion network that combines the generic features from I3D classification and the scene semantic features from BGG. And the third one is a hierarchy of networks where the first layer handles the grouping by action and the second layer handles the separation by animals. So here are the results in terms of accuracy and loss graphs. So for the fusion network, it was done without pre-training, so it wouldn't be a fair comparison. But out of the other two, the I3D only approach had a higher overall performance. Thank you.
Hi, I'm Marushi Rai, and this summer I worked on self-supervised representation learning for long complex activities using multiple modalities. I was advised by Maddie and Dr. Rowlett. We use the deep cluster approach to representation learning. Traditional supervised approaches require manual annotations to train the model, whereas deep cluster utilizes pseudolabels produced by clustering assignments to train the model. In order to test the effect of text on, the text modality, we apply two multimodal approaches. Cross-modal deep cluster uses the pseudolabel of one modality to train the other, and vice versa. We build on top of this by applying a contrastive loss with triplets picked on the fly. We first pre-train on a training data set and then evaluate by fine-tuning on frozen feature weights. Our data set for our preliminary results was formed by the intersection of how to 100M and COIN. This was to get both hierarchical annotations and narrations for our pretests. As you can see, text gives a 5.5% boost. In conclusion, text improves the representation of long complex activities. And we hope to apply our approach to how to 100M and attempt to beat state-of-the-art on various downstream tasks. Thank you.
Hi, I'm Christian Rivera, and this summer my advisor was Krishna. My project is cross-view video synthesis between aerial and street view videos. So the goal of this project is to generate an aerial view video, to use an aerial view video to generate a ground view video of the same neighborhood. The challenge was that we didn't have any correspondence sets, any correspondence pairs between the two views in the videos that we collected for training. In order to overcome this, we leveraged a shared encoding for both of the views. So the first step of this project was to learn this encoding so that the scene layout would be captured regardless of the viewing angle. So once we have these encodings, the next step was to train a neural network to reconstruct the original ground view video from the ground view encoding. After this step, the final step was to use that reconstruction neural network on the aerial view encodings in order to generate a new ground view video. So here you can see some of the results that we got. On the left, you can see the ground view video that was reconstructed from the ground view video input. And on the right, we have the new ground view videos that were generated from the aerial videos. So that's it. Thank you.
Hi everyone, my name is Danny Silva. Today I'll be presenting my work on CL-MOT, a novel approach to multi-object tracking. The problem of tracking itself involves detecting and associating object instances across frames in a video. And current state-of-the-art trackers rely on costly object bounding box and identity annotations. So to eliminate annotation demands, we propose CL-MOT, a semi-supervised contrastive learning-based approach to multi-object tracking. We require only bounding box annotations and no identity annotations. The training pipeline begins with a single static image that is horizontally flipped and augmented to create a different view of the same scene. Both images are fed through an encoder-decoder network that outputs an object sensor heat map, bounding box size predictions, and finally a global feature map. For the size prediction and detection heat map, we feed these through a mean absolute error and focal loss respectively. And for each ground truth object center, we extract an object embedding and feed each of these embeddings through a self-supervised triplet loss that will enforce feature consistency within object tracks. Once trained, CL-MOT runs online and in real time with appearance-based bipartite matching for object association. Finally, our experimental results demonstrate that CL-MOT performs on par with the state-of-the-art supervised approaches and significantly outperforms the state-of-the-art unsupervised approach. Thank you.
My name is Audrey Wiseman, and this summer I've been working on a project titled Panoptic Segmentation Without Bounding Box Proposals. Panoptic segmentation combines the ability of semantic and instance segmentation. Semantic segmentation labels each pixel as the type of object it belongs to, or the class, and instance segmentation gives each object in the picture a corresponding instance ID. So panoptic segmentation combines these two and gives each object a class label and an instance ID. The goal of this project was to create a panoptic segmentation network that does not require bounding boxes and instead find a more precise way to locate the instances. We did this by locating their centers. Lastly, we want to incorporate capsules into a panoptic segmentation network because to our knowledge, this has not been done before. The first step in our approach was to implement a baseline network called Panoptic Deep Lab, which generates semantic segmentations, instance centers, and center offsets as seen below. Then we changed our post-processing method to only use segmentations and offsets. Lastly, we incorporated capsules to match instance identification to their corresponding class labels. Here are the results from our network. We hope to improve our post-processing method, which will hopefully improve the network as a whole as well. Thank you.
Let me now introduce our new president, President Cartwright. We are very happy that he accepted this invitation from his busy schedule. He has been with us only a few months, and he has been dealing with this COVID crisis. He was hired from University of Missouri, where he was the chancellor. Before that, he was at the State University of New York, SUNY, and University of Buffalo for several years, where he started as assistant professor. Then he became department chair and the provost and vice president of research and all those administrative jobs. But most important for us is that he has been active researcher. And I was looking at his resume yesterday. He has supervised about 25 PhD students and same number of master's students to completion. And he has won career awards. These days we expect our junior faculty to get the career award. So it's a good example. Our president won the career award. And he also actually has run REU site himself, and also got a couple of supplements for REU supplements for his research grants. And also he was program director at NSF for the IGERT program, which is essentially similar to REU program, but for graduate student. And the REU was a precursor to that program. And UCF have only one IGERT. These days, IGERT is called NRT. So hopefully with the president's leadership and experience, UCF will win many more NRT grants as we have been winning REU. With this, without any further ado, here is the President Cartwright, who will present the certificates.
Thank you, Professor Shah. Who's putting them up? But thank you for having me here. It's terrific. I'll first honor, and then I'll make a few comments afterwards.
Okay, thank you. Okay, Robert. Yeah, Robert is going to go through.
Okay. Again, thank you everybody for being here. I truly enjoyed the presentations. I was fascinated by them, and I'd love to be able to talk to all of you about little details in them. But again, thank you for taking the time during a very peculiar way to do an REU, I guess. I was fascinated by you saying you had your banquet last night. I'm curious as to know how that went, but I am impressed that you're able to all be together, and the work that came out of it is clear. So thank you for being part of this. Thank you for being working with our tremendous faculty here at UCF. So with that, I'd like to do the presentations for this remarkable work. Matthew Alici, University of Nevada, Reno.
Thank you.
Jenna Bates, University of Central Florida.
Thank you.
Callie Carter, LeTourneau University.
Thank you.
Pedro Contepele, University of Central Florida.
Thank you.
Tamik DeBrito, Massachusetts Institute of Technology.
Thank you.
Joseph Fioresi, University of Central Florida.
Thank you.
Wei-Ning Lee, University of Central Florida.
Thank you.
Harushi Rai, Illinois Institute of Technology.
Thank you.
Christian Rivera, University of Illinois at Chicago.
Thank you.
Daniel Silva, University of Central Florida.
Thank you so much.
And Audrey Wiseman, Wofford College.
Thank you.
So, you know, as I said, I'm always amazed to see the great work that all of you do, and congratulations for all of the honorees. And I think actually we should do one more round of applause for all of them collectively. Thank you so much and congratulations. It's great to be able to be here to celebrate with you today. You know, the REU program certainly requires a serious commitment of your time and your brain power, and it really shows your dedication to your future, your passion for learning and for discovery, and your desire to seize an opportunity and make the most of it. As Dr. Shah said, I've been involved in this for a while myself, and I'm so impressed that you're able to do these over this summer virtually, and your ability to achieve success even under these trying circumstances. I really do want to congratulate you for that. And I hope you all feel proud of the agility and determination that you've shown. And I know it certainly will take you very far. I would like to thank again, Dr. Shah and all the team at UCF for all the work that they've done. I can tell you from experience that anyone that can have an REU program that goes for 33 years means that something's being done right. Because there's a tendency, honestly, to sometimes when things are going this long that people question whether it's still effective, what it can do. And I think what it is you saw the results. You're joining a group of other students who participated in this program that have gone on to great successes. And I think that we should give Dr. Shah and his entire team a round of applause for everything they've done. Great. This is so much about learning, right? This is about how you move into realizing that you can conduct research yourselves. As Dr. Shah said, I've supervised a lot of students. I've worked with undergraduate students in REUs, but I also experienced this too, as a father. My daughter actually did an REU experience at Vanderbilt, which is sort of funny because I didn't know she had even applied for that particular program, and she ended up working with someone that I knew who I had actually written letters of support for their tenure process, and I actually didn't know that she did that. It was unfortunate in a way because then when it became time for me to write a letter for that person for their full professor, I couldn't. I had to admit that there was a conflict because my daughter had such an amazing experience with her that I said there's a conflict. I would always write great things about this person. But I think it's about building confidence. It's about learning that you are able to do so much yourselves. This ability to actually figure out what you can do remotely and how you can work with people, it's going to pay off down the road, because I think you've had to learn additional skills that not everybody may have had to learn during their experience in an experience like this. And I think that's going to help you down the road quite a bit. I look back when I was an undergraduate, and I had to switched from business into engineering, and didn't have the math background. So I had to be learning my trig and during the time that I was taking calculus. So it was a little interesting. And I always thought that I was like, oh, this is crazy, it's hard. But then when it became time for me to move on to my PhD, during my PhD, I was working on transport of electrons and in nanostructures. And some of it had to actually rely on numerical modeling. And we didn't really have anybody in my group that knew how to do numerical modeling. And, I had already had this experience where I had to figure out things on my own. And so I was like, well, I'll just figure it out myself. So I just started reading and figuring it out, and was able to then do the modeling that we needed. And that actually is just the confidence that you build. And I hope what you're going to get out of this is that you've learned that you can do a lot of these things on your own. And that that's going to benefit you tremendously down the road. I also think another part of this that's incredibly important is that experience you have with the faculty member. You learn from the faculty member, but I can tell you too that the faculty member benefits from you. You challenge the way we think. I used to laugh with my students a lot because they would come in sometimes and they didn't know what they weren't biased the way that I was, that something may or may not be possible. right? They just thought that, oh, I'll just try this. And then you're thinking to myself, I'm thinking, I don't know if that's going to work, because we already experienced that it didn't work. But what happens is that it's that fresh look, that real desire to think differently and to try to learn more that brings so much value to everything that we do. And I thank you for continuing to be so interested in knowing more. I know that the faculty members and the grad students and others that you worked with are also going to remember you for a long time. I still remember my students that I worked with, and I remember them very well. And I tell everybody this, where I am today was only possible because of some great students. I can think about my tenure process. I can think about my becoming full professor. I can think about me moving into being an administrator. All the way along, I had one common thing, and that is I was fortunate enough to work with some great students who made all of that possible. Without you, we can't do the work that we are doing. So thank you, and please realize that this sets you up, that you are able to now go on and do great things. I hope you do consider going to graduate school. You don't have to, but I hope you do, because one of the things that we need always is we need incredibly talented people like you to continue to go on to graduate school and get your PhDs, so you become the next generation of educators who are not just educating students, but innovating and creating new technologies. And I'm a big salesperson for the graduate school experience and the PhD. I went out and in between my junior and senior year, I did an industry experience at GE Medical Systems, and I had a great experience, but and they treated me very well, and they wanted me to come back and work there. But what I realized through that process is that I wanted something more. I was not satisfied with just being asked to work on a specific project and not being asked to think creatively. And so I went on to graduate school because I realized then that what I needed is something that was going to challenge me even more than what I might see in industry, and something that gave me the freedom to really think about what I was interested in. And graduate school allows both of those. You're able to then think differently. You can challenge your own perceptions, challenge your professors, and really come up with some new and innovative ideas. And eventually, by the way, if you go through all of that, if you still want to go to industry, as Professor Shaw pointed out, a number of those graduates actually also had their own companies. And so you're still able to do that part if you want to at some point. So I'd encourage you to continue to be who you are. Continue to push yourselves, because you represent the best and brightest in this country. And we need you now more than ever. We need you to actually move us into that next generation. We need you to be the future leaders in science and engineering. And we are honored that you were able to spend some time with UCF. And thank you for doing that. Thank you for everything that you've done. And we really look forward to seeing your remarkable accomplishments in the future. Congratulations again, and best wishes for your continued success. Thank you.
Okay, thank you very much, President. We are very, very happy that you could take your time, and thank you. Okay, so this will end the session, and we will then start with the poster session.